Welcome to Lesson 2 of the Computer and Programming Introductory course. In Lesson 2, we will present an introduction to programming and describe some important terms. We will cover the computer programming, types of programming languages, different generations of languages, programming paradigms, and some important programming terms. Our objective is, by the end of this lesson, you should be able to describe basic tools, skills, software related to programming, as well as, you will get some insight into programming. Okay, so let's begin Lesson 2, by defining some frequently used terms in computer programming. Computer program. A computer program is a set of instructions for computer to perform a specific task. Programming. Programming is a process of software development. Programmer. Programming is done by professionals called computer programmers, or software engineers. Source code. The set of instructions written by the programmer is called the source code. Now you are familiar with some basic terms. Let's move ahead. Programming languages or formal languages. Let me elaborate it. Most of the time, we use informal language. When we communicate, we do not think about language construction rules. If we have to use formal language, then we need to follow language construction rules strictly. Every programming language has its own construction rule, and these rules have already been told to computer. A computer cannot process or understand the language that a human mind can do. A computer can only understand the language that is according to the predefined rules. That means, while communicating to the computer, no rule violation is tolerated. When you will program, then you will realize that there is no room for rules violation. Conclusively, we can say that computers only understand the formal language. And every computer language is a formal language, and all software is written using these formal languages. Now we are in good position to define programming language. A programming language is a formal constructed language, designed to communicate instructions and data to a computer. Now we will figure out, why do we need programming languages, which are easy to learn? Computer can only understand binary number system that consists of two digits, 0 and 1. Therefore, it is essential to provide data and instructions to computer in binary form. Let's suppose you are going to instruct computer to add two numbers, 4 and 5. You will probably do as: you will first calculate the binary equivalent of digit 4. Then you will calculate the binary equivalent of digit 5. And finally you will calculate the equivalent of plus sign. Now, the instruction to the computer to add 4 and 5 would look like as you see on the screen. This is how programmers programmed in the early ages of computer, when there was no other language except machine language. Now you must have realized that, how difficult it would be to program in binary system. In order to make programming easier, the computer scientists have developed programming languages, which contain English-like words, or codes, for different combinations of binary digits. Using any modern programming language, you can simply do calculations as you normally do in mathematics. Today, a programmer writes instructions without thinking about binary codes. Instructions containing English words and symbols are then translated into binary form, with the help of other special software, called translator, like assembler, compiler and interpreter. Now we will talk about the classification of programming languages. All general-purpose and special-purpose programming languages are divided into two broad classes. These classes are low-level programming languages and high-level programming languages. These are very important terms. Every programmer must know these terms and could be able to distinguish between them. Let us understand these terms, one by one. Low-level programming languages. Low-level programming languages are closer to computer hardware. Their prime function is to program and operate computing hardware and components. Low-level language is also called machine language. An example of low-level language is assembly language. One advantage of low-level language is, they are really fast, because the code written in low-level language are directly executable on the computing hardware without any interpretation or translation. But there are some disadvantages also associated with low-level languages. Like, low-level languages are not user-friendly. Code written in these languages is fairly difficult to understand and modify, because most of the coding follows binary instruction patterns. Another disadvantage is, low-level languages are not portable. You may have heard, or experienced hardware portability issue. For example, when you buy hardware like memory, hard disk, graphic card or processor, you usually look for hardware portability. You just cannot replace a processor from one vendor to another. This is because the low-level instructions written for one type of processor may not work for other types of processor. Let's study what high-level programming languages are. In order to make programming job easier, computer scientists have developed the languages to write instructions in more English-like way. Such languages are easy to work with, and are called high-level programming languages. The scientists also developed special software to translate English-like instructions into binary form. Such software are called compiler and interpreter. Later on, you will learn more detail and difference between compiler and interpreter. And you will install Visual Studio that comes with a compiler. Example of high-level languages are C, C++, Java, C#, etc. High-level languages have many advantages over low-level languages, such as program development and maintenance is easier and faster in high-level languages. Programs written in high-level languages are portable. That means they run on different platforms. Another advantage is, a programmer concentrates on the logic of the problem to be solved, rather than the machine architecture. I hope that you now have better understanding of low and high-level languages. Now we will look into the different generations of languages. Usually, every new language is more powerful and feature-rich than old languages. Based on increasing power, better feature set, programming style, easiness and efficiency, programming languages have been classified into 5 groups, known as programming language generations. We will now take an overview of 5 generations of programming languages, one by one. First-generation programming languages are basically binary languages. They used to program first-generation computers. Instructions to the computer were given directly in the form of zeros and ones. In the picture, shows IBM front panel, which was used to give instructions directly to the CPU. You can think of it like a keyboard of that time. An example of first-generation language is machine language. Here you see a program code written in machine language. This code will solve a simple equation, that is z equals x plus y. You can now imagine how difficult it was to program using first-generation languages. Let's now talk about the second-generation languages. Languages in second generations are a step better from the first-generation languages. In second-generation languages, computer scientists introduced symbolic codes to represent data and instructions. Like MOV for data transfer, add for addition, and sub for subtraction. The scientist also developed a translator called assembler. The job of the assembler was to translate symbolic codes into binary form. In the figure, you can see a simple instruction flow. Code with symbols goes first to assembler. Assembler translates the code into binary, and sends it to the computer for processing. An example of second-generation language is assembly language. Assembly language brought little ease to the programmers. Now compare the program written in machine language, that we have seen earlier, to the program written in assembly. Both programs perform the same task, but it seems a bit easier to write it in assembly language using symbolic code. One last thing to mention here is that first and second generation languages are low-level languages. Now let's move ahead. The languages in the third generation actually brought revolution in computer programming. Programmers started programming using words and commands, instead of just symbols and numbers. Languages in third generation are programmer-friendly, much easier to learn and maintain, as compared to previous generations' languages. Together with languages, computer scientists developed special program, called compiler, and interpreter, in order to translate words and commands into machine code. All the languages in third generations are high-level languages. Example of such languages includes C, C++, Java, JavaScript, C# and many others. In the figure, you can see a simple C language code. This code will print, "I am a new programmer," on the screen. Here, in this code you can find English words, like include, and commands, like clrscr, for clear screen, printf, for printing on the screen, and getch, for getting a character from the keyboard. We will use C# programming language, and now you better know that C# is a high-level language and belongs to third generation. Languages of fourth generation are very high-level languages. They provide a higher level of abstraction, as well as they are really fast. An example of fourth generation language is structured query language, which is used to communicate and fetch data from the database. Structured query language shows a high level of abstraction. In the figure you can see a query example. This query will fetch student ID, name, and telephone number from a database table named TBL candidate. This query will also sort the result into alphabetical order by student's name. You may have noticed the abstraction level in SQL. Lastly, we have fifth-generation languages. Fifth-generation languages are used to develop artificial intelligence and neural networks programs. Artificial intelligence programming is also called constraint programming. Constraint programming is a totally different programming approach, as compared to traditional approach. In constraint programming, instead of giving step-by-step instructions to the computer, a programmer defines a system with rules. And the computer tries to solve the task by itself. Examples of such languages include Mercury, Prolog and Lisp. In the second-last session we will discuss programming paradigms. Programming paradigms are must-know for all the programmers. Programming paradigm can be defined as, a programming paradigm is a style or a way of programming. Different programming languages offer different paradigms. Sometimes, a program is based on a single paradigm, and sometimes a single program can feature multiple paradigms. In this session we will cover 5 commonly used paradigms. These paradigms are procedural programming, functional programming, object-oriented programming, logic programming, and event-driven programming. Let's take a look at them one by one. Procedural programming style is the classic one. When you program procedural, you write step-by-step instructions to solve the problem, just like a recipe. The right order of instruction is utmost necessary in procedural programming. A new learner usually programs procedural in the beginning. Functional programming is a programming paradigm that solves problems by moving data from function to function. Here the term function, in programming context, could be new to you at this stage. But when you program, you will learn to write your own functions. A function is basically a piece of code that can run independently and perform a single task. For example, you can write a function to find out if a number is odd, or even, or if the number is prime, or not. Programming languages like C, C++, Java, JavaScript, Python and C# support functional programming. But Python and JavaScript provide a more serious functional programming style. It would not be wrong if we say that object-oriented programming is today's standard. This paradigm based on the concept of object. You as a programmer, consider everything as an object. Like a car, a human, a house, and a room. When you choose an object and present it to the computer, you associate properties to that object. Like, if you define car as an object, the properties can be car color, number of gears, number of wheels and many more. The properties you choose to define an object are called attributes. Once you have defined properties, then you define tasks that an object can perform. Like, a car can move, turn right, turn left, and reverse. These tasks are called methods, or functions in object-oriented programming. In short, a collection of properties and methods is called an object. Logic programming paradigm is based on logical rules. Logic programming uses in the development of artificial intelligence applications. A computer tries to solve a problem and comes to any conclusion based on the rules defined to it. For example, if you define two rules like, John is a student, and student goes to school, the computer will predict something like, John goes to school. The last paradigm is event-driven programming paradigm. Event-driven programming paradigm used in graphical user interface-based application. In event-driven programming, a program waits until an event occurs. For example, a calculator program in Windows is an event-driven program. Nothing will happen until you click the buttons on the calculator. Every button click on the calculator is an event with predefined action. A question may have raised in your mind, which programming paradigm you are gonna use while you learn programming. If you are not programming artificial intelligence applications, then you will practice all the programming paradigms, except logic programming paradigm. Procedural and functional programming are classical programming styles. Every new programmer begins with procedural style and then learns functional. So you will program procedural and functional. Once you have a better understanding of procedural and functional programming, then you will lift yourself and learn object-oriented programming. As we program in Windows Forms, that is a graphical user interface, so that means we will also use event-driven programming paradigm. We have reached the last session of Lesson 2. In this session you will familiarize yourself with some programming terms. Let's begin with syntax. Every programming language defines its own syntax. Syntax simply means the rules you need to follow while writing the instructions. Like in most of the programming languages, as well as in C#, almost every instruction ends with a semicolon. If you miss a single semicolon, you won't be able to run the program. Remember that the process of learning programming also involves syntax learning. If you learn syntax, then you will be able to write the program with a minimal number of syntax errors. You will save your time and your program development would be fast. On the other hand, if you ignore learning and respecting syntax, then you have nowhere to go. Your program will never run, and there is possibility that you feel yourself frustrated and lose motivation. Logical way of problem solving. Programming helps us to become a logical thinker, because you solve a problem applying different logics. To develop a logical way of solving problems could be a difficult phase for a new programmer in the beginning. You will develop it with time. Keep in mind that logical thinking and problem solving is based on practice. The more you practice, the more advanced your skill would be. Once you have developed your skills for problem solving, learning syntax remains a small job. Congratulations! We have reached to the end of Lesson 2. And I hope that you acquired new knowledge. I also hope that, as per our objective, you are now able to describe basic tools, skills, software related to programming, as well as, you now have some insight into programming.